let's talk about one last thing with domain and range. So domain and range really has two different possibilities. There is what you call discrete domain and range, or what you can call continuous domain and range. All right, so discrete domain and range, let's look at the difference between it and continuous. Continuous basically means starts, has no interruptions, then stops. Discrete basically means kind of chunks. All right, so look at this graph, right? It has 1, 2, 3, 4, 5 different points. All right, if I were to actually specify the domain, all right, if I were to actually write out the domain of this function, then I would actually have to write every single x value that is shown. All right, so let's try it out. The domain is, looks like I see the value 1.5. Then I've got the x value 2, the x value 3.5, the x value 4, and then my last x value is the x value 9. So that's the domain. Same way with the range, bottom to top. The range is, let's see, the range is actually counted by 0.25. So the range is 0.25, and the next one is 0.5. The next y value is 1.5, etc. All right, looks like the next y value is 3. And then the y value after that, I cannot see because my camera is over it. All right. That is a discrete domain. I say it's discrete because notice how it's different. There's no inequality symbols, right? There's no, this function is not connected. If it were connected like this, right, like our, and that fails the vertical line test, but if it were connected, then we could say that the domain is continuous. And this is just like a supplementary lesson, all right? If we look at this second example, all right, this is a contextual example, right? It says when he's driving at a constant rate, it takes her 4 hours to drive 232 miles from her home in Dallas to her parents' house in Houston. She creates a graph of distance versus time using the equation D equals 58t. Well, if I remember, that's my independent, excuse me, I said that wrong. I said that incorrectly. This guy is going to be my output, or my dependent variable, and t is going to be my input. So input is your domain. All right, and that's something else to specify. Your inputs are your domain. So my t for time, what is the time in this problem? Well, you're driving, it takes you 4 hours. So your domain is really 0 is less than or equal to t is less than or equal to 4. All right, while your range, your range says you drive 232 miles. So your range starts at 0 is less than your distance, which is less than 232. All right. Here you see continuous, right? I didn't have to list out 0, 1, 2, 3, 4. I didn't have to list out every number, right? Here I listed out, well, there's too many numbers for me to list. So I list out an interval, and I use inequality notation to do that. All right. Let's see if we can see an example or two. Here's another example. This has scattered points. So this would have a domain that is discrete. All right, a discrete domain, right? My domain would be, well, -3, -1, -1 again, or 0, 1, and 2. While my range would be all the y values that are listed. So -2, 4, 7, 3, and 5, right? That's discrete. Number 4, you can see that this is continuous, right? And I encourage you to take notes from this. This is continuous, all right? You have a domain that starts at 0, right? The leftmost part is 0, less than or equal to x, and it ends all the way at 9.5. And you have a range whose bottom is 0. The bottom of this graph is 0. And it goes all the way up to, that looks like it's right at 22.5. So that's a continuous domain and range, more aligned to what you were already doing.